Assalamualaikum. We from Group H. My name is Akudin, Ms. Akudin.
My name is Nurulika binti Rozahan.
My name is Muhammad Bakri.
We will introduce about Deadlock. Deadlock is a situation where a set of processes are blocked because each process is holding resource and waiting for another resource acquired by some other process.
Consider an example when two trains are coming toward each other on the same track and there is only one track, none of the train can move once they are in front of each other.
Similar situation occurs in an operating system when there are two or more processes hold some resource and wait for resource held by others.
For example, in the below diagram, process 1 is holding resource 1 and waiting resource 2 which is controlled by process 2 and process 2 is waiting for resource 1.
There is one necessary condition for deadlock, which is mutual exclusion. In mutual exclusion, at least one resource must be held in the non-shareable mode. That is, only one process at a time can use the resource. If another process requests the resource, the requesting process must be delayed until the resource has been released. Second, hold and wait. This happens when a process must holding at least one resource and waiting to acquire additional resources that are currently being held by other processes. No preemption. Resources cannot be preempted. That is, a resource can be released only voluntarily by the process holding it. After that, the process has completely passed. Not circular wait. Processes waiting for resources from the others from a circular chain. That means all waiting process from a circular chain or circular list where each process in the list is waiting for a resource held by the next process in the list. All four conditions must hold for a deadlock to occur. This is the example of a resource allocation graph. To illustrate this concept, we return to resource allocation graph depicted from the last picture. Suppose that process P3 requires an instance of resource type R2. Since no resource instance is currently available, we add a request H P3 to R2 to the graph. In summary, in the resource allocation graph does not have a cycle, then the system is not the deadlock state. If there is a cycle, then the system may or may not in the deadlock state.
Handling deadlock. To ensure that deadlock never occurs, the system can use either a deadlock prevention or a deadlock avoidance scheme. Deadlock prevention provides a set of methods that ensure that at least one of necessary conditions cannot hold. Deadlock avoidance requires that the operating system be given additional information in advance concerning which resource a process will request and use during its lifetime. Operating system also can divide for each request whether or not the process should wait.
Deadlock prevention algorithm ensure that at least one of necessary conditions, first mutual exclusion, hold and wait, no prevention, and circular wait, does not hold true. However, most prevention algorithms have poor resource utilization and hence result in reduced throughput. Mutual exclusion not always possible to prevent deadlock by preventing mutual exclusion, making all resources shareable as certain resources cannot be shared safely. Hold and wait, we will see two approaches, but both have their disadvantage. A resource can get all required resource before it starts execution. This will avoid deadlock, but will result in reduced throughput as resources are held by process. Even when they are not needed, they could have been used by other processes during this time. No preemption, we will see two approaches here. If a process requested by a resource which is held by another waiting resource, then the resource may be prevented from the other waiting resource. In second approach, if a process requires a resource which are not readily available, all other resources that it called are prevented. The challenge here is that the resource can be preempted only if we can save the current state can be saved and process could be restarted later from the saved state. Circular wait. To avoid circular wait, resolve may be ordered and we can ensure that each process can be request resolved only in increasing order of this number. The algorithm may itself increase completely and may also leak the full resource utilization. Thank you.
To recovery from deadlock, there are two categories. Category 1 is process termination. In process termination, there are two methods. Method 1 is abort all the process, abort all the deadlock process. It is delete all the process in the deadlock state. Second, abort one process at a time until the deadlock cycle is eliminated. Next is resource preemption. In resource preemption, there are three things. Things 1 is selecting a victim. We must determine the order of preemption to minimize cost. Second is rollback. We must roll back the process to some safe state, and restart it from that state. Starvation. This happens when the safe process is chosen again and again as a victim, making sure that the process can never finish. To prevent starvation, an operating system usually limits the number of times a specific process can be chosen as a victim.
My name is Rosaline Zahan.
My name is
We will introduce about deadlock. Deadlock is a situation yang terlampau.
This happens when a process must be holding at least only voluntary by the process holding it. After that, the process can completely resource cannot. After that, process can.
The system can use either a deadlock prevention or a handling deadlock. To ensure that deadlock never occur, the system can use handling deadlock to ensure that deadlock.
Deadlock prevention.
Macam mana?
Wait. Flash lah.
Sure. Apa?
No
Preemption.
preemption. Approach yang bawah tu kan?
Yeah, approach.
Approach.
Okay.
Action. Circular wait. Shi.
Process termination. Termin ke determine?
Determine.
Determine.
Determine ni. Determine ke determine?
We must determine
Pasal
the